name's William Salisbury. Today we're going to go over creating custom components in CADWorx 2016. As you can see, we already have a little piping model right here. I'm going to go ahead and create a valve that's going to go onto this threaded piping right here, plain both ends. So you're going to go ahead. First thing you want to do is you need to build your 3D body. So we're going to go ahead and create something just like that. We'll go ahead and switch to a 2D perspective. Okay, so we can see that same area that we're attaching to right here. Okay, you want to know your dimensions. Normally you can pull that from a cut sheet. So in this case, we're going to say 2 inches for the hub, 1 inch thick. Okay, so let's say that's our hub part for the valve that we want to create. Okay. And let's say between these 2 points. Correct. The entire time when you're creating this, you want to start off with 2D stuff so you can size it up just right given your cut sheet. So here I've created some really basic 2D objects that I'm going to revolve to make them into 3D. So here we have a hub and our center body. So we're going to revolve those. Okay, we revolve it. This is a sphere, so I don't have to make that 3D. I don't need this since this is a symmetrical component. Copying that. Okay, so now we've created the body for our object, as you can see here. Now normally you'd want to do this in a new drawing. That way you can save it out for future use. In this case, we're not doing that. I just wanted to go ahead and create it live. So we're in the drawing we're going to be putting it in. That doesn't cause any major issues that I know of yet. So the first thing you're going to want to do is build your 3D objects. So I have some cylinders, a cone, a sphere, and we're going to unify those using the union command. So here we go. Okay, it's all one piece. One good way to check is move it out of the way, make sure there's no little pieces staying behind, because if it's not part of this one unioned 3D object, it's not going to be in your component. So if you double click, you'll see that up top it says 3D solid. That means you're good to go. Okay, so after we have our 3D object saved, normally you want that again in a separate drawing, put it somewhere to the side. You're going to go ahead and use the user create command. Okay, and pull this over here. The first thing you need to do is come up with your name. What this is going to do is build a data file that's associated with this component, and it's going to copy this component to its own CAD file. In this case, the project I'm running doesn't have any. Normally it will pre-populate with all the data files you've already built for user shapes. So we're going to say ball valve. It's good to come up with a standard notation that you use for this. Okay, so we're going to make a socket weld ball valve, and let's say we have a particular vendor like Fisher. Okay, you can build multiple sizes into a data table, but the problem with that is you need to make sure that their qualities match up, because you're only going to specify one length right here. So as long as the length isn't an issue where you don't want the metadata to match up properly, then you can put multiple sizes in there without causing too much of a hassle. Okay, weight. It's good to have this accurate if you do center of gravity studies. It's not super essential for regular piping, if you're just running ISOs and stuff like that. But if you do stress analysis and center of gravity, it's good to have your weights accurate. Length, I don't know what this is. I should have measured it before I did it. Well, let's go ahead and say 6 inches. Okay, the length is default to inches, weights default to pounds. Okay, we're going to go ahead and put in a default description. And let's say in this case this is a specialty item, so we'll say SP-X spec. A generic way to reference the spec that's being used instead of having to actually write out the long description. SP dash. Now, the designer has the extra step that when they actually put this into the model, they will need to reference the actual numbers for that specialty item so that this is accurate. Our isometric symbol information, this is how it's going to represent on ISO if it's printed out. Okay, you see down here I have my symbol editor open. You can preview what the different skis look like from here. Here I'm in the valves category for ball valves and VB star star. The star star is a placeholder for its end types. So this could be used for any kind of ball valve, whether it's a raised face or a RTJ or threaded or whatever else have you. Okay. Unfortunately, that little VB doesn't give us enough to actually identify the ski. So we have to go to our default install directory for Windows 16, CADWorx 16, plant isogen iconfig rsdll 009, and then here's ski symbols PDF. This PDF contains all the ski symbols that come default with the software. And there's two parts that you're going to need in here. Now you just I've come into introductions, I've come down to the valve category, and this is the valve header. So all this stuff is the different kinds of valve symbology that CADWorx comes with default. I want a ball valve, which we have right here. The two things you need to recall from here are the ski and the PCF identifier. So the PCF identifier is like the category that the ski falls under. So we're going to copy that. It's valve. It's very important to get this exactly right. And in the case of the ski, capital letters do actually matter. So you need to make sure your caps lock is proper with whatever you're getting from here. So I'm saying this is a valve identifier, and that the ski is VB. This is a socket weld component, so we're going to say plain end PL. PL is for plain, is the end type identifier. So if you don't know those, you need to kind of you can leave in star star. I just prefer to be explicit when I know what end types I'm going to be using. Okay, so the first thing you wanted to do, maybe even before you started the user shape process, is setting up your sizes. I can go ahead and do that from here. I know I want it to be 1 inch, so we're already good. You can change it. You can set it reducing, but you have to do that right now, because if you make this, you can't come back and switch it to a reducing component afterwards. You have to start all over. So we're going to go ahead and select our 3D component. Click it. Right click. Okay. And want you to pick an insertion point. So just watch over here for your command prompts. So we're going to go ahead and say, now since this is plain end, it'll terminate at the face. If it's a threaded component, you need to know your engagement. In this case, we're plain end, so we're just going to grab right there. Okay, now we've identified how we're inserting the component. We also need to identify the different connections that are available. This can differ a little bit if you're doing a component that changes direction, like an angle valve or something like that. In this case, we just have 2 points that are going to be intelligent, one on both sides of the component. So we can pop that there. That'll be our main, and then it says, hey, do you have another point? If so, click it. So click it, and then you indicate the direction that you're coming from. So you're never going to come into the component. You're always going away, like as if you were piping away from the component. Which way would you go? Okay, so after you've selected all the points that are intelligent, right click. Okay, there's one more step in this process. It wants to know, hey, what kind of end connections are these going to be? If it's all going to be the same, like in this case, where everything's going to be plain end because it's socketed, you can click this to save time, and that just makes it so that whatever you pick here, it gets applied to all. Now, this list will differ depending on what your company has built up. It's good to have generics, like a generic butt weld, threaded, socket weld, and what have you. In my case, this particular client hasn't built up the standards, so they just have a lot of specific situations for the end connections here. So we have socket weld, and we find ourselves a ball valve, and you want to make sure that your classes match, even though that's not necessarily a end game right there if it's not. So we're going to go ahead and get that. We're saying socket welds the symbology, and we're good to go. It's good to check over everything, make sure you have your long and short descriptions correct. Everything right, your ski is correct, and if you have the proper information for weight and length. Now, whatever spec you're currently running, in this case I'm running my PL 150 stainless steel. Okay, that's where this data file is going to be associated with. So when you make this, you're basically copying that data file into this spec. Okay, make sure these match up with it. These should be pulled from the spec that you're currently running when you build the component. Okay, so click OK. Might take a second. There you go. And as you see, it cannibalizes the component and takes it away. That's why it's good to have it in a separate drawing. After you would do that component, after you would do that process, you would actually not save, because you want to keep that component for future use, if in case there's another component you need to build that has a slight modification from that. Okay, and now that we've done that, we're going to come over here to the spec, and we're going to go ahead and go into the project file, or the, sorry, let me grab this up real quick. Yes. So the project file is similar to older versions of CADWorx where you had a spec library. Now you have all that kind of pushed into this one big utility. So as you can see here, we are in the BW project. This is the PL 150SS stainless steel spec. Okay, so that's the one that we just modified. Now we didn't actually modify this spec. It's pulling it from a catalog, which is where the actual change happened. Go ahead and open this up so you can see what we actually produced. In this catalog, the BW catalog, go to data tables, user shapes, user 1, and look for the thing that we created, ball valve socket load fixture. Now as you can see, expand this out, make it a little more clear. This is the one entry that we just created. So we're saying that the main size is 1 inch. It's got a type 2. This is where the name of the drawing is, because when you create that, it creates a new CAD file, and that CAD file gets stored in the project folder. So you need to make sure that if you're not running off of a network standard, that everyone has that drawing copied into their system, as well as an updated version of this catalog and the spec. Okay, and these are the points that we defined as connections on that 3D component that's in this drawing. Okay, so that's where we are there. Once we opened up this PRJ, the project file, it copied that standard down. So as we go into user shapes, you can see right here the SPXXX that we just built is right here. Now you may notice exclamation mark saying, hey, we're missing stuff. Material size, if you hover, you get the little description of what's going on. Material at size 1 is not assigned, user group shapes, yada yada yada. So it tells you, hey, this is stuff that you need to fix. Normally you can fix it just by using, if you have your project specification schedule set up over here, you can just use that. I like to use the pipe schedule because that's normally something that's always set up. And you also want to have a material specified. I created a generic not specified just to get rid of those little things in the cases where your company or your client doesn't care about the material. So you can create the material. Over here you can see kind of a little preview of the catalog. In the material tables, you see these different options. The more common is the ASTM A106 or A105s. I created a not specified and allowed all the component types to pull from it. That way I can fill in that slot and kind of make it look cleaner on the in presentation here. Now some clients do want that built in, so they can use intelligent nodes in the long description. That allows them to pull from this list instead of having to retype it every time they want to type a component. They can modify everything from here. Okay. So now that we have our component in the spec, you want to go ahead and save. If you make any changes, always apply those changes before you save, because it will just remove them or erase them if you do not apply it at the component level. So we saved it here. We're also going to save it right there. Okay. And if you don't see the save anymore, you know that you are locked and loaded to go. Okay. We're back in our first piping drawing. We're going to come here. Now the component won't automatically generate here. You need to refresh to make sure you're really getting in the live data. So refresh your spec, make sure you're still running on the same size and specification. So we're going to click here. And there we go. There's our intelligent user created component, SPXXX. And we can go ahead and move that right to our piping. As you can see, we're not seeing the cross show up, so that is live and connected. And inside here, under our isogen, we can see that it has the valve VBSC. Oh, it wants to say SC for screwed, because this was a threaded line. So you want to switch that back to PL. So that's all depending on what line you're pulling into. Okay. So that should get you there. If you have any questions, just email us or call us at Drafting Book Design. Thank you.